Hello, my name's Jim Taylor and I'm your host on Current Talks, brought to you by Dale Power Solutions. Current Talks is your go-to video podcast for the latest insights and expert opinions in the critical power industry. Join us as we learn about the experiences of leading industry professionals and the innovative products and services they manage. Take a look at industry trends and technological advancements, and all the while, keep an eye on that journey to net zero. If you're passionate about or work in the power industry, you won't want to miss this. Today, I'm pleased to be joined by Andy Towse, Product Quote Manager at Dale. Together, we will be delving into the world of backup generators. With over 30 years' experience in the field, Andy is an expert in keeping organisations powered. Andy, welcome to Current Talks.
Thanks, Jim.
Could you tell us a little bit about your role at Dale Power Solutions and your background in the generator industry?
Yeah, so my role is looking after the applications team, putting the quotations together. So really looking at clients' requirements for standby power generation, providing some guidance and support for those customers. Predominantly, they're experts in their own industries, and we are experts in critical power. And they usually have a critical power need. And realistically, what they want is for us to guide them with a solution. So understand what their requirements are, what the challenges may be on their particular site, their industry, and then how we provide a standby solution that will give them and meet their requirements. Most of the industries now are very power critical with their nature of the equipment they use, whether it's a process, whether it's in healthcare, whether it's in finance, whether it's data, but their constant need for power for their operations and their systems, processes and procedures is essential.
So it would be your task to understand their industry enough so that you can then provide the solution that is bespoke to their needs.
Absolutely, because each industry has the way that they use their power is different. They've got different processes, different pieces of equipment. There's different things we need to support in their industry. So if it was in a data market, a lot of that support would be on UPS systems. We're backing up that uninterruptible power supplies.
And that's where UPS is.
And that's where UPS is.
Excellent. What are some of the key responsibilities you've got in your current role?
So some of the key responsibilities is to oversee those projects that we're looking at, the types of equipment we're looking to supply the customers, how we approach those, working with the team that puts those quotations together, and providing that support for the end client, but also the teams within the business.
For those unfamiliar, including myself, would you be able to explain, please, what an emergency backup generator is and does?
Yeah, so an emergency backup generator is a unit that provides electrical power. So effectively, if the main supply is interrupted for any reason, or there's a fault, or there's an issue with that main supply, then a standby generator is there to provide electrical power in that instance. So effectively, the site will still be supported even if there is a power outage.
And if there's a power outage on the main system, your system would just kick in straight away?
The system would kick in, the generator would start up, then would start to support the site network and distribute around the actual site itself. So there might be certain key critical loads that come on first. So if you're looking at in a healthcare environment, you'd look at critical areas such as life support, neurology, intensive care, those type of stuff. If you were looking in a banking environment, you would support the data first, and then you would start to support the ancillary equipment.
So what are the primary type of generator systems that Dale supply?
So it's a mix of standard solutions and bespoke generator solutions. So some of those can be standard canopied units, going forward with more bespoke containers, plant room installations, depending on clients' requirements, space availability, power requirements.
So when I think of generator, for example, there's the thing that's towed on the back of a truck that's dropped off somewhere. That would be a standard canopied solution?
That's a standard canopied solution. That one happens to be trailerized. So when we're looking at a site application, that will be positioned somewhere on site. It'll sit on a plinth and it will be a static, but it's the same principle. So that's very standard, very small in space, and then depending on the nature of site, they may grow in size for the power requirement, but also if there's more noise requirement, there is more autonomy in the running of the machine, how long it has to operate for. All of those has to be developed as part of the site solution. So
brilliant. And how much difference is there in the type of applications that those are used for?
There's a dramatic difference, both on power requirements. So we can go from 50 kVA to 2.5 MVA, 3 MVA. Those can synchronize together. So you can be looking at, as we said, power requirements of small town versus the power requirements of just a residential property to, so that the difference in size is physically increases. The more power you need, the bigger the machine gets, the larger the airflow, the larger the amount of fuel required.
And do the generators have different applications? So not just is the type of generator that you use differ depending on what the customer needs?
Absolutely. If you put in an environment that is quite a harsh environment, you might be looking at the actual paint specification of the actual enclosure that you're putting in. You might be the design of the enclosure, so it makes sure that water sheds off the roof, so you don't have the roof. It could be in a saline environment. It could be right next to the coast. It could be, as well. Obviously, we're based, in that type of environment, something we're very aware of. So, you've got to look at that application and ensure that the equipment you build and you provide to the client meets where their location is, their application, and how they're going to use it.
So the design procedure starts from the client and you discussing what the client needs, you understanding the client's business, and then from that starting point, you then go down and you're able to understand what the machine is required to do, and then the environment the machine is going to be placed in, and then that helps decide how to build the machine.
Absolutely, it's that initial conversation saying, getting the key points out there. So what is critical to you in the sense of space, location, environment, operation of the machine, and then what are the constraints of the actual site itself? And that is a conversation which is good that both parties are engaged in that, because then we understand what matters to the customer, and then we can give alternative solutions because there might be different ways of doing it.
So could you give me an example of one of the smaller solutions that you guys have put in place?
Yeah, we've put solutions in place where we've had to fit elements in a building. So we walked into a plant room. It's a story I chatted with the guys earlier where we walked into a room. They said, we want it to fit in this room. The room's full of equipment. They go, oh, it's okay, we're going to remove that equipment. But we had to make the machine fit into the opening of the room. So it was almost like a letterbox to take the machine in and then lower the machine down. So that type of application is that we'll have a look at the room or the environment we're putting the unit in, and then develop the design of that so it meets that criteria. In that instance, we had to make it a certain height, so then as it went through and could be taken into the room, and then modularly build everything back up again within the room.
Wow. And what about some of the situations where you've had to deal with either harsh environments or maybe the level of autonomy that the machine needs?
Yeah, so we look at that environment. We'll look at where it's located. We might make suggestions of how the client locates it. There might be certain areas within their facility that provide a little bit more protection for the machine, but also maybe the orientation of the actual machine itself. From an autonomy point of view, we can look at tank location, the size of the tank, and whether we can do that in singular or multiple tanks.
Excellent. What are some of the common challenges customers face with power reliability?
I think what they're facing is that the power network continues to change as we look at the renewable network. We look at the development of the massive demand in people's power requirements, as we said earlier, where we're looking at how people use laptops, how we use those that are critical for all our industries to how we support it. So there is a change in how they're being used, but the fundamentals are it's still power. It's still critical to that requirement, and it's still something they need to operate.
So with everybody using more and more power in their daily lives, I mean, we've all got multiple devices. Obviously, businesses are now completely reliant on this kind of thing. How does Dale specifically address that challenge of making sure that it's available all the time?
Yeah, so it's back to looking at the reliability of the system, how somebody wants it to operate. So you don't just look at a standby generator and say, it just provides power. How is it then going to deliver into the site systems? And how do they need that to come on? What do they see as the most critical element of their business? And how then do we feed into the other elements? But we want to make a safe, reliable system that works every time it's required, But some of that also requires the service and maintenance and ongoing support of the equipment. So it's not just the supply, but it's how the equipment's maintained and managed through its life cycle.
Is there a type of customer you work with, or
our customer base is broad and varied? So it will go from residential type properties to banking facilities to oil and gas to healthcare to finance to anywhere that has a critical power need, whether that's for safety of data, whether that's safety of process, or whether that's safety of life.
Wow, truly across the board. And these vary in size as well.
They vary dramatically in size because depending on the site you're looking at or supporting, their power demand does vary. So when you're looking at larger scale industrial sites, the demand will be like a small town. Some of them are almost heading into that level of of power. If you've got a centralized plant on a data site, or you're looking at a healthcare site or a process site, you've got multiple units into the megawatts of power. So.
How does Dale approach the customization of generation installations?
So we'd look at a specific requirement, so understanding the site constraints. The first bit is how are they looking to use it? Where is it going to be located? How are we connecting it? So the first bit is to get that base bottomed out for the design, but then we would use our applications team. Obviously, I head up that team, but also use our in-house mechanical electrical design engineers to then work out what will then be the best solution. If it's a space challenge, we'll look at what can be fitted into that space. There might have to be compromises made. You might have to accept a slightly higher noise level, but it will fit in the space, or you might look for a lower noise level and look for an alternative location. So it's looking at different options, because obviously that's what we do. We understand what we can do with the machine and where it can fit, where it can't. We understand electrically how it can connect into the system, and we can speak to the clients and go through that with them, how it will interface with their systems.
So from a very layperson's point of view, you're building modular systems, or you have like base systems that you then apply to other people's circumstances? Like, how does that kind of work?
Yeah, I think there's a mixture. So a lot of the systems now, people like a modular system, as you mentioned, Jim. So they're looking either for a very standard canopied unit or a bespoke enclosure that can be basically just placed on site. So all the work on the unit is done prior to it going to site. So that it's installed in its own enclosure, its own soundproofing, could have its own fuel system in there, or connects to a local fuel system around it. But we can still put them into buildings, into plant rooms, but we've got then to look at the openings. So you're looking at airflows that can go up to 30, 40 cubic meters a second just to actually cool the machine. So we've got to take that consideration in, take the noise level of the particular machines, because they all vary, and also how we exhaust that, how we put the fuel system, how long they want them to run for.
And that would then inform what sort of ongoing support and maintenance you guys would be doing?
Yeah, the important bit about the design is not only for the fact that how you install it, but how you're going to then maintain it in the future. If you do something in the initial design that then limits to how you can maintain it, look after that machine, you're looking for life cycles of 20, 30, 40, 50 years out of some of these machines. And if you're looking for that, then you have to consideration in the first design is to make sure that you can have that relevant access. You can do the work you're going to need to do. As a machine ages and with time, there's certain things you're going to have to do mid-life cycle to keep to give the full life cycle of the machine.
And retaining that information on an institutional level is Dale's problem.
It is to look after that, but also those considerations, because a client wouldn't look at a machine and understand how you're going to have to maintain it and what parts of it you're going to have to maintain and what likely the things you're going to have to change through its life cycle.
Do you have any examples for us about how the solutions that Dale have provided have either enabled a client to carry on with their work or mitigated any of the risks associated with the type of work that they do?
Yeah, we had a data site that we supplied the equipment and looked after that had a major HV failure outside. Somebody was doing some works.
Sorry, 1 second. HV?
High voltage.
So okay.
Something above 400, 415 volts that you would normally see in houses and buildings,
yep.
But more to, we call it HV in our industry. Yeah. It's more a medium voltage, so it's something like 11,000 volts. So that's a network that tends to be around. So in the substations that are around the area that we all see, from the network operators, then they supply the power to that substation. Then it comes down at low voltage into the actual sites themselves. There was some damage on that local HV network. And then the site then had to run for a number of days. In fact, it went into weeks because of the amount of damage that was done by the local construction works. And so to replace that, it was going to take such a long time. So they had to run on the generators. It allowed the site to maintain its data, critical nature. It kept operating and required more maintenance through that period. But it showed the necessity of generation on site, and there were other areas that would just do the same thing. There's a downtime cost if you lose your power on a critical site.
Absolutely. With the increasing focus on environmental sustainability, could you give us a little bit of an understanding about how Dale Power Solutions are addressing the Stage 5 emission standards?
Yeah, to meet this Stage 5 emission standards, we know that we have to have machines with after treatment, so effectively SCR technology, so selective catalytic reduction. That means that the emissions from the machines can meet the regulations. So whether that's for NRMM, which is non-road mobile machinery.
Okay.
Yeah, I was going to say an easy one to say, but maybe not. And the other is for the low emission zones. So there is an increasing number of low emission zones, not just in London, but in the major cities in the UK. So by using that technology, working with our suppliers, whether we're looking at mobile equipment or whether we're looking at fixed installations, we can achieve those emission levels to meet that environmental requirement.
So what would be a non-road mobile?
So effectively something that is like a standby generator. You'll see that canopy generation, if you had a failure in a utility network, you'd notice that somebody would drop what looks like a square box at the side of it, which is a canopy generator unit. And so that would be a mobile unit. So it's not running on the actual road itself, but it's actually
But it is a mobile
station,
unit.
but it's mobile. It can be moved to different locations.
And so if one of those is inside a low emission zone, it would still need to adhere to the Stage 5 emission standards.
Absolutely. And because it's mobile as well, it also has to adhere to that. But it's that requirement for meeting those emission standards and being able to do that, which requires more equipment on the actual machine itself.
And Dale are implementing that across the range?
That's implemented for different applications. So again, a bit like we chatted earlier about the applications, you got to look at that application. What's the levels that you're looking for in applications? What are the restrictions of applications? Because it does increase the size of the machine and the equipment. So there are areas where that can be challenging. So we have to look at that as part of the application design as well.
And we're back to that becoming part of the bespoke solution that Dale provides for all of their customers.
Absolutely.
Could you explain the role of hydro-treated vegetable oil, or HVO?
Yep, HVO. With the obviously move to use greener technologies and greener fuel sources, still to utilise something that can be run for a long period of time. So you need for most standby generation to meet a certain autonomy level, so the amount of hours it will run for, you need a fuel source on site. So if that fuel source is not mineral diesel, which has been in the past, the move to use HVO, which effectively is a plant-based, so a renewable source of fuel, is something that lots of customers are moving their standby requirements for. So if you're putting new equipment in, most of the new equipment is running on HVO.
And alongside the benefits when it's being burnt, does that also have any front-end benefits, like when it's growing? Is the CO2 emission from that kind of thing significantly decreased?
The CO2 from the emissions from the machine is reduced by up to 90%. So it's a dramatic reduction just by using that fuel, as well as the fact it becomes a renewable source.
And what about the experience of the customer? Do they notice a difference in using this type of fuel?
There's very little difference from the operation of the machine. The only thing you have to be careful of, if you previously had mineral diesel or in the fuel tanks, in the fuel system, the fuel pumps on the engine, you may have to just do a little bit of work to those, make sure that it's fully cleaned before you put HVO in. It's slightly different in constituents. It's very close, but it does have a cleaning property that sometimes gives you some things you didn't expect. So.
Okay. But once you've made the switch, the actual experience of using it, there's no loss in power or change in actual function, for the end user like myself that just literally plugs something into the wall, I wouldn't notice necessarily.
Once you've made that switch, it operates in the same way as that would any fuel source. So it still produces a power, very similar power output from the machine, and same functionality, and then same elements to maintain as you go along.
So you've explained there that HVO is the replacement for mineral diesel. How do you see the hydrogen technology evolving, and what kind of things are Dale putting in place to see this technology through?
So there's lots of development within utilisation of hydrogen for hydrogen engines, from hybrids where there's hydrogen injection into engines. So a lot of the engine manufacturers are putting some work and effort into those areas. And we see that as a technology that is developing and will be coming forward into the standby generation industry. But like any developing technology, there are different pieces that the guys are trying to put in place that improves its functionality, reliability, and its operation through its life cycle.
And is that technology ready for the kind of critical power situations that you are providing solutions for at the moment?
There are units ready at the moment. However, there are some cost prohibitive elements to some of those solutions for a mass market. But it's as the technology develops, the cost reduces, and effectively the utilisation and operation of those will increase.
But that's something you can see at a strategic level at Dale that you're seeing coming down and
absolutely, and
fully expecting to implement.
Yeah, and we constantly work with our specialist suppliers and engine manufacturers to look at that and when that the implementation of those equipment needs to come into the market.
Brilliant. What do you think some of the key challenges and opportunities are with the transition to greener fuel and power generation economy? And how is Dale, what are you guys doing to prepare for that?
I think that some of the key challenges are some of that change, as we mentioned, the change in the fuel sources, that there's certain things you need to make sure you've done with the equipment. There's certain pieces of equipment you need to have alongside the generator. So we call it ancillary equipment that sits alongside. So that means the exhaust system, that might be in the fuel system that you do and put in place. That means that you've got a reliable unit that's not going to just work for now, but also works for the next 10, 20, 30 years. So it's that reliability in the initial design to give you the operability for the client.
So with these kind of timescales that you're talking about with the solutions that you're providing, if you have a 20-year solution going into place, 20, 30-year solution going into place, and you're confident that HVO or hydrogen or something else is coming down the line, how do you build in those kind of fail-safes to make sure that the equipment you put in place isn't going to become obsolete?
I think looking at those and developing the equipment with those technologies. So HVO has been one of those where it can be used with that existing technology. And I think as they go forward, some of the solutions where there is a mix of hydrogen used on equipment, or there is always an element of infrastructure that could remain, and some infrastructure may have to be adapted for any new fuel sources or new solutions.
So is that maybe where we need to get to with the hydrogen thing, so that you can actually literally replace core units with, this is now something that runs on hydrogen, that's now an old unit and it's now obsolete and we need to move on to this one?
You've got to look at that, and there is a modularization of some of those, so you can make it where the connection to the actual facility is quicker, and then that can be replaced by an alternative unit if that requirement or that development in technology changes.
And I guess, again, just to hammer home the point, this is the area where Dale would be providing the expertise to the client in order to be able to provide the solution that is necessary for their sector.
Absolutely, yeah. We'll be looking at how it works for that industry, how it works in that environment, and how it works for that particular client or project.
Well, thank you very much, Andy. It's been an absolute pleasure having a chat with you today. Is there anything that you feel that we haven't covered that you would want the people who require these sort of systems to understand the kind of things Dale can offer and how you guys can help them out?
Yeah, I think for everybody that's looking at and seeing the requirement for standby generation is to think of all the parts, is a thorough understanding of how you want to use the machine, understand your operational philosophy early, what really matters to you, and also, like ourselves, speak to experts in that to be able to take you through that journey. We understand the elements of the generator unit, and we can take you along that line. You don't need to learn each step. We can take you through some of that experience and give you alternatives. And then, if we need to find compromises of what we have to do with the design or with the equipment, those can be done up front. Everybody agrees them, and it's nice. It gives a better clarity to any project that you're working on.
So that would be a question at that point. The client reaches out to Dale. You guys go in and help them prepare the understanding of what it is that they are looking for. And then you guys build the solution, install it, maintain it, look after them for the rest of the time.
Yeah, that's it. Yeah, we're looking for looking after the client for the whole life cycle of the machine.
Spectacular. Well, thanks very much. Thanks for tuning in today. If you found our discussions interesting and want to learn more about what we do, visit our website at dalepowersolutions.com. Or if you prefer a chat, call 0330 999 3000. We're always here to help and answer any questions regarding your power needs.